Welcome back. Today, we're going to tackle one of the biggest challenges in modern software. How do you go from just running an application to building a system that can actually take care of itself? We're talking about making our apps truly resilient, self-healing, using some of the most powerful tools in the game, Kubernetes and Azure DevOps.
So let's just kick things off with the big question, right? Your app is live, it's out there, people are using it, but what happens when it's 3 in the morning and some random part just crashes? Or what if your marketing team knocks it out of the park and your traffic suddenly goes up by 100 times? How do you deal with that without constantly being on high alert, manually fixing everything? That is the core problem we are going to solve today.
Okay, let's get right into it. First up, we're going to set the stage by really digging into the modern app challenge. The specific things that keep developers and operations teams up at night.
At the end of the day, it really just boils down to these 3 big headaches. You've got your unexpected crashes. How do we make the system smart enough to just fix itself when something breaks? Then there are the sudden traffic spikes. How can we get the system to automatically grow when it's busy and then shrink back down to save us money when it's quiet? And of course, risky deployments. How do we ship new code to our users fast, but also in a way that's totally safe, secure, and free of human error? So, let's tackle that first headache, those random, unexpected crashes. The real solution isn't about getting faster at fixing things. It's about building an application that knows when it's sick in the first place. And that brings us right to our second section, automated health checks. The main tool we're going to use for this in Kubernetes is something called a probe. Seriously, just think of it like a tiny little doctor that Kubernetes assigns to every single part of your application. Its entire job, 24/7, is to constantly ask, hey, you doing okay over there? And then jump into action if the answer is no.
Now this is where it gets really interesting because there are 2 main types of probes you absolutely have to know about. First is the liveness probe. It asks a really simple question. Is this app completely broken? If that probe fails, Kubernetes acts like a paramedic with a defibrillator. Boom, it just restarts the container to bring it back to life. But then you have the readiness probe, which asks something a little more subtle. It asks, hey, I know you're running, but are you maybe too busy to handle new requests right now? If that one fails, Kubernetes acts like a bouncer at a packed club. It just stops letting new people in, new traffic, until the app says it's ready to go again. It doesn't kill it, it just gives it a break.
So how do these probes actually check on your app? Well, they've got a few different tools in their toolkit. The most common way is just to send an HTTP request to a special health check page, like your app.com/health. Or it can run a specific command inside the container itself, or even just check to see if a network port is open. It's super flexible, so you can define exactly what healthy means for your application. All right, so we've got our system healing itself when things go wrong. That's huge. Now, let's talk about that second big headache, crazy, unpredictable traffic. This brings us to section 3, where we're going to build a system that can scale up and down all by itself.
In the world of Kubernetes, you've got to think about auto-scaling on 2 different levels. First, there's the pod level. That's your application itself. You can scale horizontally, which just means adding more copies of your app, or you can scale vertically, which means giving the copy you have more power, like more CPU or memory. Then there's the second level, the cluster. These are the actual servers your app runs on. If you run out of space for all your new app copies, the cluster autoscaler can just automatically add more machines to the whole system.
Now this is a super important detail when we're talking about resources. You have to understand what happens when your app hits its limits. If your application uses up all its allowed memory, Kubernetes sees that as a total disaster. It's a catastrophic failure, and it will restart that part of your app immediately. But if it hits its CPU limit, things are different. It doesn't restart it. Instead, it throttles it, which basically means it slows it down. It keeps it running, but it just gets less processing time. Knowing that difference is absolutely key to setting things up correctly.
And this is the perfect way to picture the difference between those 2 pod-level scalers. The horizontal pod autoscaler, or HPA, is exactly like a grocery store opening up more checkout lanes when the lines get long. You're just adding more identical copies to handle the rush. It's perfect for most modern apps. The vertical pod autoscaler, or VPA, is more like swapping out a small delivery truck for a giant semi-truck. You're making the one you have much, much bigger. The HPA is way more common, but the VPA definitely has its place, especially for older apps that weren't designed to have multiple copies running at once.
Okay, so our system can heal itself, and it can scale on its own. Awesome. But the final piece of this whole resilience puzzle is all about deployment. How do we actually get new code from a developer's laptop into production safely and reliably? And that brings us to our 4th section, building smarter, safer pipelines with Azure DevOps.
Let's talk about secrets for a second. API keys, database passwords, all that sensitive stuff. The absolute worst thing you can do is just paste them directly into your code. A slightly better, but still pretty risky approach is to store them as plain text variables right inside your pipeline. But the best practice, the way the pros do it, is to use a dedicated secrets manager like Azure Key Vault. This way, your pipeline never actually sees the password. It just has permission to ask the Key Vault for it at the very last second, right when it's needed.
And as our pipelines get more and more complex, deploying to a dev environment, then a test environment, then production, we really don't want to be copying and pasting the same code over and over again. That's a recipe for disaster. This is where templates come in, and they are an absolute game changer in Azure DevOps. The best way to think of a template is as a reusable function, but for your deployment process. You define all the steps one time, and then you just call that function for each environment.
So you might be thinking, okay, a reusable template is great, but my database URL for development is totally different from my production one. And you're absolutely right. That's the exact problem that variable groups are designed to solve. They let you create these little bundles of variables for each of your environments. And this is the magic part. These variable groups can link directly to Azure Key Vault. So you get this beautiful, secure bridge between your reusable pipeline code and all your environment-specific secrets.
So we've covered probes for healing, autoscalers for handling traffic, and secure pipelines for deploying our code. Now, for our final section, let's put it all together and see how these individual parts create one cohesive, super powerful system that's ready for anything the real world can throw at it.
So let's just tie this all together nice and neat. We started with the problem of application crashes. The solution to that is automated healing, and the tool we use is Kubernetes liveness probes. Then we had the problem of overwhelming traffic. The solution is elastic scaling, and our tools are the Kubernetes HPA and the cluster autoscaler. And finally, the problem of insecure manual deployments. Our solution there is secure automation, and we achieve that with Azure DevOps Pipelines and Azure Key Vault. See, every problem has a specific, powerful tool designed to solve it.
And that really brings us to the end. When you put all these pieces together, you fundamentally change how you work. You move from this reactive state, constantly putting out fires and fixing what's broken, to a proactive state of building what's next. When your foundation is this solid, this automated, and resilient, you free up all that time and energy to actually innovate. So the final question isn't about maintenance anymore. It's about creation. Your system is now resilient. So, what will you build next?